Good day. For those of you who do not know us, we're the instructional staff for ECE 150, Professors Hiran Patel and Werner Dietl, and Douglas Harder. In this talk, we're going to introduce the concept of debugging and using the debugger. So, this is the last in a sequence of topics on C assertions, code development strategies, testing, commenting your code, using print statements for debugging, and finally using this debugger. So in this topic, we will describe the purpose of the debugger, look at how it is used, and while we're at it, explain some of the benefits. Now, using logging to find bugs can be frustrating, especially if you have to start inserting multiple print statements throughout your code. In some cases, you only have to add one print statement, and that might actually be sufficient to find what's wrong with your code. But if you're not sure where the problem is, you might find yourself putting 3, 4, 10 different print statements all over the place. The debugger does all this work for you. It prepares a different executable, one that tracks all the variables, and then the debugger displays how they are changing as the code executes. We're going to try this on a program that actually works correctly. Now, the term debugger tends to actually scare students. So that's what we're going to do. We're actually going to start by showing how the debugger actually just allows you to step through code and see the variables changing and allowing you to determine whether or not the code is doing what you think it should be doing. All right, here is our program. This program calculates the GCD of two numbers. The reason we use this is because there's a number of local variables and a while loop. Okay, so let's get going. Now, in Eclipse, or whatever IDE you are using, you can execute your code in something called debug mode. Now, in Eclipse, rather than pressing the green play button, you press the button with the green bug. Why bugs? Well, actually, the term bug has been used to describe technical issues since the mid-1800s. Thomas Edison even used the term. There is a funny story that on September 9th, 1947, operators actually found a real bug, that is a moth, in a computer, and they taped it up and labeled it as first actual case of bug being found. Again, a play on words, meaning they found a bug, but this time it was a real bug. It was Rear Admiral Grace Hopper, who also worked on this project, who popularized the term bug and debugging in computer hardware and software development. Now, when you debug your program, the very first question you're asked is this dialog, which asks if you want to change perspectives. Now, a perspective in Eclipse simply is a different selection of panels, in this case, using panels that are more appropriate for debugging. Please do switch, and probably just remember the decision. Now, for Eclipse development, Eclipse offers two different primary perspectives. There's others, but the more useful ones are the default, the C or C++ perspective, which is seen here on the left of these two, and the debug perspective, which is on the right. So you can switch between perspectives by selecting either one as necessary. Now, once you're executing your code, you will notice that the perspective has changed. On the right-hand side in the panel, you see a number of possible choices. The one that we start with has all local variables and parameters, their type, and their values of the currently executing function. So here we have main. Main has two local variables, m and n. They are both of type int, and as initialization has not yet occurred, they both currently seem to have a value of 0. Your code is also marked up. As you can see here, there is a arrow to the left of the 7 indicating that this is the statement that is to be executed next. And of course, the entire statement itself is highlighted in green. So at this point, this statement in your code has not yet been executed. It's waiting for you to give it instructions. So, what are the relevant controls? Well, first and most important is, of course, the button to stop debugging, but just as important are the stepping control buttons immediately to the right of the stop button. These will allow us to step through the program and see the changes each statement makes. Now, the 3 step controls include these 3 buttons, which indicate to step into. As you can see, it seems to have an arrow going into some code. The step over function, the arrow indicates that it seems to be jumping over something. And the step return, it's coming back out of what it went into. Now, the step into button, or you can use F5 as well, will execute the next statement unless there is one or more function call within that statement. If there is one or more function calls in that next statement, then it will step into executing the next function call that is scheduled by the compiler. Note that it will not step into any function call in the standard library, for example. It will only step into the functions you yourself have authored within the Eclipse environment. The step over button, or also alternatively F6, will simply execute the next statement. If there are function calls within this statement, they will also automatically be executed. All you will see is the result of that statement being executed. If there are no function calls in a statement, step over is equivalent to step into. Now, the step return function, or also F6, finishes executing the current function from the current point and returns to the statement that contained the call to this function. This button is actually inactive when in main, as you cannot step return from main, as that just finishes the execution of your program. Another button that is very relevant is the resume button. The resume button continues execution without any further stepping until either the program finishes or a breakpoint is reached. Something we haven't discussed yet, but we'll get to that. And a few other features. But the only other feature we're going to discuss in this topic will be breakpoints. Alright, so now we're executing the code. With every single slide, I'm going to simulate pressing the step into button. So first we step into, and that executes the statement we're at right now. And so now we see that the value of the local variable m has changed. Press step into again. All right, so we executed the statement that initialized the value of n, and as we can see, the value of n has been changed, and that change is highlighted in the right-hand panel. If we now select step into again, we will now go into the GCD function with the arguments m and n. Now, this was a horrible choice on my part. I foolishly had the local variables of main be exactly the same as the parameters of the GCD function. So, bad choice on my part. However, on the right-hand panel now, you see not the local variables in main, but rather the two parameters of the GCD function together with the values that were passed to the function call. Now, at this point, if you were at home, you could just continually select the Step Into button and walk through and watch the execution of this function. Right now, there are no local variables, but when you go into the while loop, we are suddenly within the scope of the local variable r. And so as long as we're inside the while loop, you will actually see the local variable r appear on the right-hand panel. Nice. However, as we don't really have time to do that right now, I'm going to demonstrate a different feature. Now, if in the right-hand panel I select or click on the value of the parameter m, then we see information about this parameter, including all the details at the bottom, its decimal representation, hexadecimal, binary, and octal or base 8 representations. Well, that's not what I'm here for right now. Instead, because I've clicked on that cell, I can now type the number 0 and hit enter. I've just dynamically changed the value of that parameter while the debugger is running. So now, before I have executed the statement in the left-hand panel, I have now changed the value of m to be 0. So now the condition m equals 0 is indeed true. So if we now select Step Into, we are now going to return the value of n. A little odd, but makes sense, I guess. So now that we've stepped into at the end of the function, we just go back and finish executing the cout statement and carry on to the return statement. Because I artificially changed the value of the parameter m to 0, the value of the argument n is what was actually returned, which in this case is 774,180. And if you take a look at the console output window, this is actually the value you will see there. Alright, so if you select Step Into one or two more times, the main function will exit and the program will terminate. You can either go back to editing by then selecting the C/C++ perspective, or you can run the debugger again. Now, at this point, you may have discovered one small weakness with this concept of stepping through a program. Suppose you have a very large program and the issue doesn't actually manifest itself until later on in the program. Do you really want to step through every single statement until you get to the code that you believe to be buggy? The solution to this is an idea called a breakpoint. A breakpoint is a way of flagging to the debugger that it should stop at a particular statement. So a breakpoint is associated with a specific statement in a program, perhaps the first statement in a function. So then you can execute the program, and rather than stepping through statement by statement, you can have the debugger just execute the program as per normal, but as soon as it reaches a breakpoint, then the debugger goes back into the phase where you can indicate that you should step through the program, or you can indicate to the debugger to keep on executing, and it will keep on executing until it either reaches the next breakpoint or the program finishes executing. Your program can actually have multiple breakpoints, and you should put these anywhere you believe there is an issue. Now, we're only going to discuss breakpoints here, but there are many other features of debuggers as well. But we will get into those later in this course. For now, we want you to become familiar with stepping through a program and using breakpoints. Alright, now to set a breakpoint, let us assume that you suspect that there's a bug in the GCD function, and you think the bug is in this while loop. So perhaps you'd like to stop only once we get to this while loop. Specifically, let's assume we want to stop at the line that initializes and declares the local variable r. So what we're going to do is we're going to select that line, and above the line number we will right click. Okay, so by right clicking there we see a drop down menu, and we will select toggle breakpoint. Toggle means turn on and off. So if the breakpoint is not there, it will turn it on, and if there is a breakpoint there, it will turn it off. So once you've selected toggle breakpoint, you will see now that a blue dot appears on that statement. Okay. So now when you launch the debugger, you're here at the start of main, but you don't want to step into or step over all of these statements before you get to the line with the issue, specifically line 24. Consequently, from the menu, you will select the play button. That will continue executing the code until either the program finishes or it reaches a line with a breakpoint down here. Once we get to the line with a breakpoint, it will be just as before. We will not execute that line yet. It will appear in green, and then you can select either step into or step over and continue executing from that point on. Because the breakpoint is in a while loop, if you hit the play button again, it will just jump to that. It will keep on executing until it reaches a line, that line again with a breakpoint. So you can actually have multiple breakpoints in your program, and you can toggle them on and off even while the debugger is executing. Okay, so this is a nice way to jump where you believe the problem is, and then in the right-hand panel you will be able to observe all of the values of the various variables, local variables and parameters. And as I showed before, you can even change them. Now, you may be wondering, how do you actually debug a program? Because up until now, all we've done is watch how a program executes. Well, that's it. The debugger simply gives you access to the state of the program while it is executing. You can see the variables change. You can see what happens when a statement is executed. It is much easier to become familiar with how the debugger works by watching how it works with code that is actually doing what it's supposed to do. For example, you might try the same thing we just did right now, but try calling the GCD function with smaller arguments, say 15 and 25, and watch how it works. Later, when you have a program that simply does not work the way you expect, at that point you can then switch to the debugger and watch how the state changes. Of course, to use the debugger correctly, you actually have to know how the program is supposed to be working for you to discover when the statement that makes the incorrect assignment actually executes. The debugger does not find the problems for you. The debugger helps you discover the problems in your code. Okay, following this topic, you now have been introduced to the debugger. You understand that all it does is execute the program, but while doing so, it displays the values of parameters and local variables, and it allows you to execute one statement at a time. You know you can step into the execution of functions, or you can step over the execution of functions and just see the results of those function calls. You are aware that you can even change the value of parameters and local variables on the fly while the debugger is executing. You now also know that you can set breakpoints that allow you to execute the program until the line in question is reached, in which case you revert back into debug mode where you can execute one line at a time or one statement at a time using step into or step over as you desire. Here's the references, acknowledgements, the colophon, and a disclaimer. Cheers!